right? So as usual, I'm going to go through the tutorial sheet for week and try to do as many of the questions as possible, right? So if you look at the tutorial sheet for this week, let me show you. Um, this is the tutorial sheet. I'm not sure if you can see it clearly, but if you cannot, just go to the website and have a look at it, right? This is the tutorial sheet for week 10. And as you can see, there are 5 questions. So I will start with question 5 and work backwards. Okay, right. So okay, let me read question 5 for you. Basically, it says there are 288 voters in California, and out of that, 141 voted for the in the presidential election. And it also says there are 216 voters in Colorado, and out of that, 125 voted in the presidential election. And the question is to find an approximate 95% confidence interval for the difference in proportions uh, of voting in California and Colorado, right? Okay, so to do that, we need to we need to go back to what we learned last week. You may recall from last week, we talked about these 4 different confidence intervals, each for the 2 sample case, right? So the first confidence interval is for the difference in population means when the variances are known. The second one is for the difference in population means when the variances are unknown but equal. And the third one is for the differences in population means when the variances are unknown and not equal. And the final one, which is this one, is the confidence interval for the difference in proportions. So obviously for this question, for this question here, right, you need to use the final one, because this is the only formula that involves you know, the only confidence interval formula for differences in population proportions. All right. So I will use this formula to work out the answer. So let me put this back, right? So this is question 5. All right. So if you cannot hear me, or can you guys hear me now? Okay. Hello guys. Can you hear me or see me or see my writing? Okay, thank you, thank you. If you have problems again with the computer, please let me know, because this morning I had terrible problems with the computer, uh, as you know. Um, so this is the formula I'm going to use, guys, to answer question number 5. Okay, right. So first of all, we need to write down everything that is given to us. Now, X bar is the sample proportion for the first population. So it's the proportion of people who voted in California, which is 141 out of 288. And Y bar is the proportion of people who voted in Colorado, right? Which is given in the question as 125 divided by 216. And the question also gives you the value for M. M is the sample size for the first population, from the first population, and N is the sample size from the second population. So these are all given to us in the question, right? The next thing we need to figure out is we are looking, if you read the question, guys, we are looking for 95% confidence interval, right? Which means, I'm sure you know, this 100 times 1 minus alpha is 95. Okay. Hello, guys. Oh, so all of a sudden, what is happening here? 100 times 1 minus alpha is 95, right? Which implies that alpha must be 0.05, right? And this implies that Z1 minus alpha by 2 is Z 0.975, and this is equal to 1.96, right? So what I'm going to do now, guys, is this is the formula that we have. I'm going to put all this data into this form, into this formula, right? So you will get the following. You get right. This is what you will get if you sub all this into this, right? And if you do the simplification for this, this is the lower limit will be this, and the upper limit will be right. So basically, the interval is on the negative real line, which means that the proportion for California is always less, is smaller than the proportion for Colorado. In other words, the proportion of waters in California is smaller than the proportion of waters in Colorado for the presidential election, right? Is this clear to you guys? Or are you okay with this? Hello, guys. Talk to me. Are you okay with this, guys? Hello. Okay, thank you. All right, can I move to the next question then? Okay, so that's question 5. The next question I'm going to look at is question number 4, which is this one. Again, if you cannot see this, please look at the course website, which contains the PDF file for these questions, all the questions. Right here, you have two brand A and brand B, and you're given this data here, right? You're given the sample sizes, the sample means, and the sample standard deviation. Now the question is to find a 95% confidence interval for the difference in population means, assuming that the two brands are normally distributed with a common but unknown value for sigma squared. All right. So going back to this formula sheet, which of these three, I mean, clearly it must be one of these three, right? Now, which of these three should we use and why? Hello, guys, talk to me. Which one of these three you think we should use for the question number 4? Hmm? Hmm? Can you guess? I mean, I just read the question for you guys. It says that assume that the two brands are normally distributed with a common but unknown value for sigma squared. So clearly we need to use the second one, right? Yeah, Millie, you are right. Yeah, so we need to use this one because this is the one where we are assuming that the variances are unknown but equal, right? So this is the one we should be using. Thank you, Millie. So I'm gonna use the second formula. Excuse me. So this is question number 4. Question number 4. So I'm going to use the formula that, let me write down the formula again. excuse me. All right, this is the formula for the confidence interval for question number 4, right? So I'm gonna show you how to use it, right? Now, if you go to the question, right? If you read the question one more time, excuse me. If you read the question one more time, it says that your x bar is equal to 21.8 and your y bar is equal to 18.9. And it also says that M is the sample size for the first brand, which is 12. N is for the second brand, which is also 12. Now we need to compute SP. Now you may recall SP is the pooled sample standard deviation. And the formula for that I gave you in the class. If you look back in the notes or the videos, if you look back in the videos, this is what you will see. This is the formula I gave you. Okay, now M is 12, so 12 minus 1 is 11, times the sample variance for the first sample is 8.7, so it's 8.7 squared, right, plus 11, and the sample variance for the second is 7.5 squared, okay? And here, this is gonna be M plus N, which is 24 minus 2 is 22, right? So if you work this out, this will be 65.97, okay? And finally, we are looking for 95% confidence interval. So your 100 times 1 minus alpha is 95, which implies that alpha is 0.05. So your T M plus N minus 2, this guy here, is going to be T with 22 degree of freedom, 22 degree of freedom, and 1 minus alpha 2 will be 0.975, okay? And if you read this off the table for the T distribution, which is in the course website, this is what you will get. I mean, a couple of weeks ago, I showed you how to read this. I mean, if you haven't seen that video, please do so on how to read values of the T table, right? Okay, now we got all this data. What I'm gonna do is I'm gonna sub everything that we have here into this formula, right? So you will get the following. You will get 21 minus 8 minus 18.9 plus or minus 2.074 multiplied by SP. SP is the square root of, excuse me, SP is the square root of this, right? So it's going to be the square root of 65.97 multiplied by 1 over 12 plus 1 over 12. Okay. All right. So if you simplify this, the lower limit will be this, and the upper limit will be this, right? So this is the 95% confidence interval for the difference between the mean absorption times for brand A and brand B, right? Okay, guys, are you okay with this? So the crucial part for questions like this is to determine which of the formula to use. I mean, if you get that wrong, then your entire answer will be wrong. So you have to be careful. You need to read the question very, very carefully and figure out which of these four formulas that you should use, right? Okay, okay, guys. The p-values for the 1 and 2 sample test. Yes, just George. Yeah, you should go to the course website, George, right? And click on there's a link called formulas. There's a link called formulas on the course website. And you should go to that link. There is a table for reading the t values. I thought I mentioned this last time. Anyway, you should go to the course website and click on the link called formulas and go to the very bottom of that link. You will see there are tables for reading the chi-square distribution. There are tables for reading the t distribution, and there are tables for reading the normal distribution, right? Okay. All right, guys. Any other questions on this, guys? Talk to me, guys, please. Any other questions on question number 4 before I go to the next one? Hmm? Hello, guys. Are you okay? No questions? You okay? All right. So let me move on to the next number. So we're done with question 4. So the next question I'm going to do is question number 3. So this is question number 3. Uh, so here basically we have two different estimators. This is an estimator for mu, and this is an estimator for sigma squared, right? And the first part of the question is to show that they are both unbiased. Okay, and okay, we'll get to the second part later. So let's try to do the first part. So this is question 3. This is question 3, part 1. So you have mu hat equal to nx bar plus my bar divided by n plus m. Okay. So, and we need to show that this estimator is unbiased. Remember, to show that something is unbiased, right? We need to find the bias of it, okay, and show that the bias is equal to 0. You remember that, right? So that's what I'm gonna do here. So this is the definition of bias, right? Okay. Now I'm going to show you that this is equal to 0 in a while. So the first thing I'm going to do is I'm going to take the n plus n outside because it's a constant, right? Then in brackets you have n. I don't know what's happening with the computer again. It's giving me trouble. This is okay. This is what you have. Okay, and this is n. The expectation of x bar is simply the expectation of 1 over n. Excuse me, 1 over n times the sum 1 to n of the expectation of xi. Okay, like this. Okay, right now I'm gonna take the summation in, sorry, the expectation inside the summation. So this will be, I don't know, just a minute. I think I'm having problems with, still having problems with the computer still. I don't understand why. Okay, plus M, this should be M, guys. All right. And clearly these two guys cancel out. Okay, these two guys cancel out. And the expectation of xi we know is mu. Okay, and the expectation of yi we know is also mu. Okay, so what you have is 1 over n plus m. This is n times mu. This is m times mu minus mu, right? So this is clearly equal to 0. So hence we have shown that mu hat is unbiased for mu. All right. Is this clear to you guys or not? Hello, guys. Yes. Okay. Thank you. Thank you, Sophie. All right. The next thing we need to show, the next thing we need to do is to show that the estimator for sigma squared is also unbiased, right? All right. So this is question 3. Sorry, question 3, part 1. Still. Right, the estimator for sigma squared that is given to us is, if you read the question, it says n minus 1 times sx squared plus m minus 1 times sy squared divided by n plus, excuse me, what's happening? Jesus. N m plus n minus 2. Okay, this is the estimator for sigma squared. And we need to show that this 2 is unbiased for sigma squared. So to do that, I'm going to compute the bias, which is the expectation minus the parameter, right? So this is the expectation of okay. All right, the next thing I'm going to do is I'm going to take the expectation inside. So this is going to be, this is a constant, so you can pull this outside. Okay, right. Now, you may recall from one of the things that we did much earlier on in the course. I think it was, this is stuff I did in week 2 or week 3 in the course, that the expectation of the sample variance is equal to the population variance. If you don't remember this, please look back on week 2 or week 3. I showed you how to prove that this guy is equal to this guy, right? Right? Now this is equal to, now these two guys together gives you m plus n, okay, minus sigma squared, right? So these two guys cancel, right? So you get this to be equal to 0, right? So once again we have shown that, oh man, sorry, what's happening? I don't know. Jesus, sorry guys, I don't know. There's some issue with this. Give me a sec again. Hello guys, just hang on a minute. I don't know why this will keep doing this. Just give me, just wait for a second. Just be patient, guys, please. Yes. Okay, just give me a second, guys. Okay, all right, it's okay now. Okay, so as you can see, we have shown that the bias is equal to 0. Hence we have shown that this is unbiased for sigma squared. Okay, all right. Is this clear to you guys or no? Hello, guys. Talk to me. Are you okay with this proof that I have just shown you? Thank you. Thank you, guys. All right. All right. The next part that we need to do is part 2 of question 3, which is asking you to find the variance of mu hat and then find the limit as n and m go to infinity, right? So let's try to do that. So this is part 2. This is question 3, part 2, right? So we want to find the variance of mu hat, right? Now, mu hat, we know that mu hat is yeah, okay. So I'm going to show you how to find the variance of this. Now, if you take the n plus m outside, right, and take the variance inside, you will get n squared times the variance of x bar plus m squared times the variance of y bar. Okay. Now, okay, so x bar, you can write it as variance of 1 over x bar is n, right? It's 1 over n. Yeah, 1 over n times the sum of xi. And y bar, you can write it as 1 over m times the sum of yi. Okay. Right. Now, I'm going to do the following. I'm going to take the n outside of the bracket. So it's going to become n squared And similarly here, if I take the m outside of the bracket, it will come like this. All right, clearly these two guys cancel out, right? So what you have is the following. You have this. Now variance of xi is given in the question as sigma squared, and the variance of yi is also given as sigma squared, right? So this will be this is n sigma squared plus m sigma squared. Okay, right? And clearly this simplifies to sigma squared divided by n plus m, right? And this clearly goes to 0 as n goes to infinity or m goes to infinity. All right, so this completes question number 3. Is it okay, guys? I mean, this we did this kind of stuff long time ago when I talked about bias, or when I talked about bias in MSc. I did similar calculations. Yeah, are you okay, guys, with this? Hello, hello, guys. Okay, all right. So that's so we're done with question number 3. So let me move on to the let me so we're done with 3. So let me move on to question number 2. So here we have 150 light bulbs from brand A with the mean lifetime of this and the standard deviation of this, and 200 light bulbs from brand B with the mean lifetime of this and standard deviation of this. The question is to find a 95% confidence interval, assuming this or this. Right. Okay, let's see. So this is where, once again, you need to figure out which formula to use, right? You need to figure out, you see, so let me go back to the sheet here. This is the sheet I showed you. Okay. Right, to do the first part, of this equation, the first part of question 2, right? Which of these formulas do you think we should use? See, it has to be one of these 3, right? Because we are looking at the difference in population means. So it must be either this one or this one or this one, right? Yeah. So this is here we are assuming that the variances are known, the population variances are known. And here we are assuming that the population variances are unknown but equal. And here we are assuming that the population variances are unknown and not equal, right? So, so the question is, okay, returning to this question, I mean, it doesn't say anything about population variance in this question. It only says it has a mean lifetime of this and standard deviation of this. It doesn't say anything about population variance being known. All right. So basically, we need to use this one here. We need to use number 3 of these 3, right? Now, but let me show you. But there is a trick. I will talk about it now. All right. So this is question 2, part 1. The formula we're going to use is Okay, this is the formula that we're going to use, right? Let me put this in the box, right? Okay, now going back to the question, let's go back to the, let's see what is given to us. We are told that X bar is equal to 1386, yeah? And we are told that Y bar is equal to 1218. We are told that M is the sample size for the first brand A is 150. We are told N is the sample size for the second brand, which is 200. Okay. And we are also told that the standard deviation, which we have to assume is sample standard deviation, right? Sx is equal to 114. Yeah. And Sy is equal to 90, 98. So these are the things that are given to us. And we asked to find a 95% confidence interval, right? So basically 100 times 1 minus, okay, let's forget about this for the moment. Now, before I talk about this, can you look at these two figures? You see, M and N are the sample sizes, right? Okay. I mean, these are pretty huge sample sizes. I mean, in statistics, anything above 25 is regarded as large. So 150 and 200 are very large numbers in statistics. Yeah. Yeah, it is a 95%, Jess. I will come to that, Jess, in a minute, Jess. Just hang on a minute. I'm talking about the sample sizes now. All right. These are two very big large numbers, right? In that case, you can approximate, because yeah, you can do this approximation because of because of the large M and N, right? I mean, so you can have, I think this is a property I mentioned in the video on students T. You should go back, you should look at that video. One of the properties I stated is that the student T variable approaches the standard normal as the degree of freedom approaches infinity. So that's the property I'm using here. Because these two guys are very large numbers, right? You can approximate this by the standard normal, right? Okay, so this guy here will become as follows. X bar, which is 1386 minus 1218 plus or minus. Now we are looking for 95%, which is Z 0.975, right? One, okay, because alpha is 0.05, so 1 minus alpha by 2 will be this, right? And then Sx squared will be 98 squared, and Sy squared, sorry, not X, not 98, I mean 114, I meant to say 114. This is 1114 squared, and Sy squared will be 98 squared, right? Divided by M is 150, and N is 200, right? Okay, okay, guys. So if you work this out, the the confidence interval that you will get is this. Okay, this is what you will get. You see what I've done, right? And this is a very complicated term to calculate using table, right? And for that reason, I have used this approximation, and this approximation is valid because of the large sample sizes, M and N. I mean, anything above 25 is a large sample size in statistics, right? So for these samples sizes, you can certainly say that you can approximate this by this, right? Um, the video is, I think it's on students T, Drew. So if you look at the video on the students T distribution, you will see this. This is, I mentioned this briefly. That is the student T random variable approaches the standard normal as a goes to infinity, right? Okay. All right, guys. Any other question, guys? This is okay with you guys or not? Hello? Okay, thank you. So this is only part one of question two. All right, now let's return to part two. So we've done part one. Part two is to do the same thing, assuming that the variances are equal, right? So in that case, the formula, okay, the formula that we need to use is this one, because this is the only formula where we are assuming that the variances are equal but unknown, right? So we need to use this formula here, right? So I'm going to show you. So this is only, we just did part one of question two. Now part two, part two of question two. All right. We're gonna use this formula here. This is the formula I'm gonna use. Right? And once again, I'm gonna use the fact that this guy here, because M and N are large numbers, right? We can approximate this guy here by this. You see, it's the same argument as in the first part of question two. That is because the degree of freedom is a very large number, right? This can be approximated by this, right? Okay, now let's write down okay, SP, by the way, SP squared is the pooled sample variance, which you may recall, this is the formula I gave you. This is the formula I gave you for the SP squared, you may recall, right? Yeah. So if you put in the numbers, M is 150, so M minus 1 is 149. Sx squared is 114 squared. N is 200, so 200 minus 1 is 199 times Sy squared is 98 squared divided by this guy here, M plus N minus 2 is 150 plus 200, take away 2, right? Now, if you work this out, this will be 11056.32. All right, so this is the pooled sample variance. Right, now going back to this, X bar, we know X bar from the first part, which is 11386. Y bar is 1218, plus or minus. This guy we already know from the first part is 1.96 multiplied by SP is the square root of this. So it's the square root of 11056.32 multiplied by 1 divided by n, which is 150, 1 divided by n, which is 200. All right. So if you simplify this using a calculator, this is the confidence interval that you will get. All right, guys. So this completes Question number 2. Are you okay with this or no? Okay, thank you guys. All right, so finally, question number 1. Let's go to question number 1. So we're done with question 2. Now question 1 is not difficult. It's pretty straightforward actually. I mean, it's question 1 is let me show you if I have time. I'm not sure if I have the time, but maybe I will just do the first part of question 1. Um, so here, basically, you have a random sample from a Bernoulli, and the confidence interval for the P is the population proportion, uh, which you may recall from last week that the issue the the confidence interval for a population proportion that I gave you in the notes is this. Okay, this is the confidence interval for population proportion, right? The first part is asking you to find the width of the confidence interval. Now remember the width of the confidence interval is the upper limit minus the lower limit. So the upper limit here is uh, this is the upper limit, right? And the lower limit, this is the lower limit, right? So if you take the difference between of these two guys, you will get the width to be equal to the following. Right, this is the width, right? And clearly this width is proportional to if you leave out these two are constants, right? So this width is proportional to x bar times 1 minus x bar divided by n. So that's the first part of question number 1, right? And the remaining parts are pretty straightforward. I mean, are you guys okay with this or no? I mean, this is pretty straightforward stuff. The part 2 and part 3 and part 4 are not really difficult, right? You should be able to do them. If you have problems, call me. I mean, contact me. But anyway, I will post the full solutions to all the 5 questions on Thursday of this week. So if you go to the course website on Thursday, you will see the full solutions to all 5 questions. So there will be the typed solution, there will be the handwritten solution, and also a video solution, right? Okay, guys. So I'm sorry for the trouble with the computer this morning, and I was really bad. I'm using somebody else's right now, so once again, my apologies. Okay, but just take care and have a great evening wherever you are. And if you have questions, please feel free to contact me 24/7 by email, Skype, Zoom, or phone. You know my phone number is 0161 273 2941. All right, guys, have a great time, great evening. Right, bye.